Do we start?
Yes, sir.
Okay. So from router one, if you want to reach on 10.10.10.0 subnet, which is not directly connected to you, that means your router does not have information of a 10.10.10.0 subnet. Okay, so you always require a protocol which will carry that information on your router. Okay, either it will be static or either it will be dynamic. What static says, if you want to reach on any specific destination network, you have to manually define on it. Okay, along with the best path, then only we are able to reach on that network. Okay, so same on router one, you have to statically or manually put a route for 10.0.0. Something, whatever the network is. Okay, along with the best path 1.1.1.2. 1.2 is the directly connected interface. Sorry, directly connected neighbor interface. Directly connected neighbor interface. It is not your own interface. You can define your own interface in some different cases, okay, and in some different way also. So now the second point, did all understand about this or any doubt?
Got it, sir.
In first point, all are cleared about this or you want to ask something? No. Okay. Second point, administrative distance. How many of you know about the administrative distance? Huh? How many of you know about the administrative distance? Okay, what is the administrative distance for the static routing protocol?
It's
It's a
one.
one.
It's a one. So what exactly it is?
One, sir.
Why we use an administrative distance in any of the routing protocol? In any of the routing protocol, why we use a concept of administrative distance? Anyone?
Sir, it is low administrative distance means trustworthiness of the path actually, protocol.
Trustworthiness of the path. Okay. In a simple word, if you will say, okay, to give a preference or to give a priority on a routing protocol. Okay. Is it or not? If suppose in our scenario, if you have a configured static routing as well as you have configured rerouting a protocol, it's up to you. Okay, you can configure multiple routing protocol as many as you want. Okay, so for example, you have a configured static routing protocol, then you have configured rerouting protocol, then you have configured EIGRP, OSPF on same router. On same router, you can configure as many as you want. Okay, but it will prefer only one. It will give a preference or the priority to only one of the routing protocol. To define that, which will be the preferred one, they use what administrative distance. Okay, lowest the administrative distance, highest the priority. Guys, keep your mic shut. Okay. Lowest the administrative distance, highest the priority. And AD value is used to rate the trustworthiness on a routing information getting by your neighbor router. Administrative distance is used to rate the trustworthiness, how much trust you give to your routing protocol. So it depends on your administrative distance value, a value which is in integer form, okay, which is in a numeric form. The lowest the administrative distance, the highest the priority. Okay, so the administrative distance of static, for example, administrative distance of static is 1, and the second one is having a rerouting protocol. Let me show you. Suppose in this scenario, sorry, in this scenario, you have configured a static routing protocol plus rerouting protocol. Okay. Default the administrative distance of static routing protocol is 1. The default the administrative distance of RIP is 120. Now you say to whom it will give a preference. Either it will listen to static routing protocol to find out the best path, or it will listen to
Static
rerouting protocol static routing. They clearly said the least the administrative distance, the highest the priority. Okay, so between static and rerouting protocol, by default they will give a preference to a static routing protocol. Okay, so it's administrative distance, which is very important to understand when you are running with a multiple routing protocol. When you are running with a multiple routing protocol in your topology. So in your topology, if you have multiple, they will give a preference according to the administrative distance. And administrative distance should be less than the other one. Okay. Now, the next point is, it is a classless or a classful protocol. The behavior of this routing protocol is classless or classful.
I think classful, sir.
Classless routing protocol. It is what? It is classless routing protocol. What exactly? Yesterday also we have something seen about the classless and classful. Okay. What exactly the classless routing protocol? Classless routing protocol always carry the actual subnet marks while advertising its network. While advertising its network. And the classful routing protocol does not advertise any sub network, any subnet marks along with a network ID, Let me explain you what exactly the classless and the classful is. All of you understand about the subnet marks, I think. All of you know about the subnet marks?
Yes, sir.
Okay. Also with the subnetting, all of you know about the subnetting?
Yes.
Sir.
Okay. Let me take an example. All are able to see my screen, right?
Yes, sir.
Now, between router 1 and router 2, you have directly connected interface. Okay. Behind your router 1, we have 3 subnetwork, which is 172.16.1.0. Second one is 172.16.2.0, and the third one is 172.16.3.0. 3 subnetworks you have configured behind your router 1. Okay. Out of this 3 network, you only want to advertise only these 2 subnetworks. One is 172.16.1.0 and the second one is 172.16.2.0. You don't want router to get the information of 172. Sorry, it is 172. You don't want router 2 should get your information, which is 172.16.3.0 subnetworks. Why? Because as per the requirement. Okay, there you have some you can say the critical server which you don't want to advertise this network to router to in production. Okay, you don't want to advertise. Okay, you said I agreed. Okay, we will advertise only 2 subnetwork, which is 172.16.2.0 and one is 172.16.1.0. Now, along with any classful routing protocol, Classful routing protocol, you decided to advertise 172.16 1.0 and 2.0. Okay, so with a classful routing protocol, you have advertised these two networks. Okay, router 2 will get this two network information with that routing protocol, and that routing protocol is classful in behavior. How it is? It is in classful in behavior. Classful in behavior means they will never carry the subnet marks. They will never carry the subnet marks. What router 1 will advertise to router 2? Router 1 will advertise router 2 that we have two subnetworks, which is 172.16 1.0 and the second one is 172.16 2.0. This will the information which classful routing protocol will advertise without any subnet marks, without any subnet marks. Okay, what router 2 will do with this subnetworks? What router 2 will do now? What will be the next step of router 2? Any of you? Router 2 will accept it and play with it, or it will do some any other thing?
It will pass the information to neighbor router.
It will pass the information to neighbor router, but before passing the information to neighbor router, what it will do? First, it will kept into its routing table, is it or not?
Yes, it will update the routing table.
It will update the routing table, is it? Okay. Before updating the routing table, what do you think? Is it the complete information or incomplete information? 172.16 1.0 and 2.0.
No,
Is it the
so
complete
net,
information or incomplete information?
Sir,
subnet is not, net
incomplete
mask is not there.
information.
हाँ, क्या?
Network is
Hello.
not there. Subnet is not there.
Subnet mask is not there. That means it is an incomplete information. Is it or not?
Yes.
Yes, sir. It's incomplete only.
Okay. So before storing into its routing table, what it will do? It will make it complete. It will make it complete. But how? This address belongs to which class? Class B.
Class B.
Okay, and class B is having a default subnet mask of what?
Slash
60.
60. Yes.
Okay, /60. What it will see? Oh, both are a similar network only. So what it will do? What exactly it will do? Okay, by practical also we will see it. Okay, what it will do? It will keep it like this. 172.16.0.0/16. Inside this major network, the both network 172.16 1.0 and 2.0 false or not?
Yes, sir.
Yes.
It all
Yes,
are
sir.
covered in the same.
All are covered. Okay, all are covered. That is good. My routing table get short. Okay, very good. Now, what do you think? Is it a drawback or it is the advantage?
Sir,
It is
Is
maybe a
it a
also
drawback.
drawback
including
or advantage?
3.0. It is the
It is
drawback
also
actually. It
include.
is also including 3.0.
Okay, that is the drawback. The advantage is what? Our routing table gets short. Okay,
Short.
but the biggest drawback is what? The biggest disadvantage is what? Okay, what we decided to hide with my neighbor router, which is 172.16.3.0. Now, is it open or not?
Yeah, it's open, sir.
It's open. That means what? Router 2 will able to communicate with a network or with a sub network which is 172.16.3.0. That what we decided to hide it with others. Is it?
Yes, sir.
Okay. So classful routing protocol is never better, is never good. Okay, that is why they did not continued it. Why? Because there are multiple drawbacks. There are multiple drawbacks. Now, what will be classless behavior? All of you understand about the classless? Sorry, classful. Now, what exactly the classless behavior? Classless routing protocol says, classless routing protocol says we will carry, always we will carry the actual subnet marks along with the network ID, along with the network ID. Now, while advertising network, which is 172.16.1.0 and 2.0, it will only advertise it what? 172.16 1.0/24, and the second one is 172.16 2.0 slash 24. Okay, it will not advertise. uh, It will only advertise what? 172.16 1.0 and 2.0. Okay, along with the subnet mark /24. Now, is it a complete information or incomplete information?
Complete information.
Now, is it your complete information or incomplete? Complete information. So what router 2 will do? Router 2 will store as it is whatever they get it from router 1 to its routing table. Okay, without having no more information of route. Sorry, this one 172.16 3.0. Okay, so in this case, router 2 will only able to reach my network, which is 1.0 and 2.0, no to 3.0. Is it? So classless routing protocol are always good as compared to classful routing. So what static is? Static routing protocol is a classless routing protocol. It is not classful. Okay. Any doubt?
No, sir.
No, sir.
All of you got this 3 point. The first one, manually need to configure. Second point, administrative distance. The default administrative distance is 1. Okay, if you want to change, you can change it between two what? Between what value you can change it if you want to change? Anyone? Between what values you can change your administrative distance?
I think till 10.
Till 10. Bro, RIP is having an administrative distance of 120. Any one of you? What are the administrative distance values?
Sir, you're asking about the administrative value.
Administrative distance values, yeah. I'm talking about the administrative distance value. Nobody. The administrative distance value lies between 0 to 255. 0 to 255. Whereas 0 means directly connected network. The directly connected networks, this one. The directly connected network, this one. The directly connected network will always have an administrative distance value of 0, the least one. Okay, that is the reason your directly connected networks are always reachable to you. Okay, and 255 means whenever you will advertise any 255 administrative distance with the network. Okay, 255 means no traffic will be passed via this. That means you are keeping a signboard of work in progress. Okay, don't go via this route. Okay, so 0 to 255. 0, the directly connected interface, and 255 means what? No traffic will be passed via this route. If you want to configure the administrative distance value manually, you can configure it from 1 to 254. 1 to 254. The values are 0 to 255. Okay, but you can configure from 1 to 254. 1 default for static, 2 No one is having 3, no one is having. Okay. Similarly, 120, which is reserved for RIP. 110, which is reserved for AIGRP. Okay. These are, sorry, 110, OSPF 90 for AIGRP. Okay.
Sir,
These
can we
are
change?
the default values. In static, you can change.
We can change the static from 1 to 7.
1
Means
to 7, 1 to
main any
70,
value.
or 1 to 700. No, 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 not 700. 700 you can change or not?
No, sir. I mean, we can change the
Hmm.
value of E for static 1 or between 255.
0 to 255, but 255 is the reserve value for no traffic will be passed. Okay, so you can change up to 254. They have allowed you a values of 1 to 254.
But I have a question here regarding
Yeah,
administrative distance.
very good. Tell me, ask me.
Basically, I'm not getting the point why we need administrative distance in static routing or even in dynamic routing. What is the basic purpose? What the logic behind it? Why we need it? And how exactly it works?
How it works? CBA, bro. In these two routers, on these two routers, okay, let me explain you one topology over here. Let me explain you a simple way. Okay, you will come to know what are the logic behind using of administrative distance. Okay, you have three routers. One is router 1, router 2, and router 3. Is it?
Yep.
Okay. On a router 3, you have a one network. On router 3, you have a one network which is, for example, 192 something, 192, 168, 1.1. Okay. Through static
Okay.
routing a protocol on router 1, through static routing a protocol, okay, you have decided, okay, to reach, okay, via this path. You have to configure it manually in static, okay. So what you have decided to reach via this path. Are you getting me?
Yes, sir.
Okay, in static routing a protocol, you have to configure the network along with the best path, all the things manually, statically. Okay, nothing will be automatically. Okay, so what you have decided, you will go on router 3 network via router 1 to router 2, router 2 to router 3. Is it? Okay. Along with static routing a protocol, you don't trust on static, so you have a configured one more routing a protocol which is RIP or any. Okay, RIP routing a protocol. According to the RIP, automatically, RIP is a dynamic routing a protocol. Automatically, they have calculated this path is the best path to reach on destination network 192.168.1.1. Is it? Now, router 1, in its routing table, they have a network information of 192.168. But how many paths they have? How many paths? One is from router 2, which is static defined. Okay, and one is directly from router 3, which is defined by RIP. Is it?
Yes, sir.
Okay, but now decide on router 1 which path it will choose to reach on 192.168 subnet. Tell me
The directly connected one, which
why?
administrative distance is
Why?
0.
Why?
Oh, because
Why?
it's near to that and it's directly connected as
It's
well.
near.
So,
Okay, you will go to routing a protocol and
yeah, it's
say it
directly
is
connected.
near. That means you go via this route only. Is it? Or they are going to use some algorithm, or you will go with to RIP routing a protocol and say, oh, this is near to you, go via this route. Or are they going to use some algorithm? A protocol is going to use some algorithm. Of course, they are going to use some algorithm. Am I right or not?
Yes, sir.
Okay. So they are going to use algorithm known as what? Administrative distance. To give a preference to what? Your routing information. Okay. Now, I am getting a same network information via static routing, also via RIP routing protocol. Am I right? Okay, what we have defined on this topology. Okay, static, which is advertising the administrative distance of 1, and the second protocol, which is advertising an administrative distance of 120. Now I have to decide to whom I will trust. To whom I will trust. So what administrative distance is? Lowest the administrative distance, highest the priority you have to give. This is the algorithm of administrative distance. Getting the basic of administrative distance, why they have used the administrative distance between the different routing protocols to give a preference, to your routing protocol when you are working with a multi-protocol environment. When you are working with multi-protocol environment. Okay, so in this topology, you have multiple protocols. One is static, and the second one is RIP routing. Okay, so now I have to decide which protocol I will believe to, I will trust to. Okay, so that I will give a preference according to the administrative distance. Whoever will advertise the less administrative distance, to whom I will give a preference. Clear? Or anything else? Should I define more?
It's clear, sir. Thank you.
Okay, it's very simple. When you are working with a multiple routing of protocols, okay, there you require a administrative distance to give a preference to one of the routing of protocol, to whom I will listen, to whom I will believe, to whom I will trust to reach on my destination. Okay, so that it is decided by your administrative distance. Whoever will advertise you the lowest administrative distance, to that you have to give a preference, priority, or the trust.
Here I have a question.
Ah.
Like we
Yeah, yeah,
have
yeah, yeah. Tell
administrative.
me, I am greedy for the questions. Yeah.
Let's say we have a stat 1 to 2 254 administrative distance count the number.
Yeah.
So why we need these number all the time? For each network we need to provide another count number, or it could be one for all the networks for the static
One
routing.
for the all network. Okay, if it is advertising by rate, see how many network you have doesn't matter, does not matter. If it is advertised by static, all will have the administrative distance of 1. Okay, if it is advertised by rate, it will be 120. If it is advertised by XYZ, it will be XYZ. Okay,
No,
it
no.
doesn't matter
Basically, I'm
how.
sorry to interrupt you here. Basically, my question was, as you
Uh,
told us earlier, that the administrative distance is
value
254,
254. Very good. Yeah, I
254,
told.
and
Yeah.
we can use any one of them, or we should be constant with the one.
No, 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 no. You can use any one of them. The default value is 1. The default value is 1.
And why we need to change the value? What the reason
See,
behind? Why should
what the
we
reason?
change?
Now in this topology, okay, same concepts are there. Same concepts are there. What static says in this topology, to whom you have given a preference? Static. Why? Because it is advertising you the lowest administrative distance. Agreed?
Yes, sir.
Okay, agreed. Okay. Now, my manager says, okay, this is the longest path to reach on 192.168 1.0 network compared to router 1 to router 3. This one is having the least path. This is the least path, the shortest path as compared to the router 2. If you will go via router 2, that means you have to cross like something like 2 kilometers. From here to here, it is 1 kilometer, and from router 2 to router 3, you have 1 more kilometers. That means you have to go via 2 kilometers to reach on router 3. Is it? Okay. When you have a shortest distance of 1 kilometer, why you are preferring the longest one? Why you need it? Okay. So in that case, what you will do? You will say no, this one is static routing a protocol. It is giving the least administrative distance. That is why we are preferring this. No, that time what you have to do, you have to change your path. And how you will change it? How you will change it? Okay, you will advertise the highest administrative distance as compared to rerouting a protocol. Okay, while advertising the static routes, you will mark that route with an administrative distance of 121. What you will mark?
21.
121. Okay, now router 2 will get the information through static routing of protocol, but via what? 121 administrative distance, and RIP is advertising with a default value of 120. Now you say, to whom it will give a preference?
The lowest value is of the RIP 120.
Yes.
To whom it will give a preference? 120. Okay, so
120,
this
of
is the
course.
place where we play with your administrative distance. If you want a manipulation or a path change in your topology, there you play with your administrative distance value. You got it?
Now it's clear to me. It's very understandable for me now. Thank you so much, sir.
Okay, the default value is 1. The default value is 1. If you are not assigning any values, any AD values manually, so default it will take what? 1. But if you want a path change in your topology or in your environment, okay, you have to play with your administrative distance value.
Sir, I have a question.
Tell me.
Can we change the default value of dynamic routing protocol like RIP
Yes,
or
yes, man.
SPF?
Not only in rerouting a protocol, you can change the value of any routing a protocol. Any.
Thank you, sir.
Okay,
So
that is
by
the reason
changing
they have given. Tell me.
by changing any default value of any routing protocol, like it could be a RIP, it could be BGP, OSP, whatever. So it won't create any kind of mess within the network if we change the
No,
default
that
value.
you have to take care. That you have to take care. If you are changing on one router, that means you have to change on every other router also.
So what is the best practice we have to follow rather than we create a mess within the topology?
Use a default value.
Okay.
Use a default value. Okay, or else you have to take care on every other router that you have changed the values properly. If you will play with the routing protocol, surely routing protocol will also play with you. Got the points? Any doubt regarding this?
No, sir.
Okay. So basically, like static routing protocol is not having that much of a points or that much of a features to be defined. Okay. What is the command to configure the static routing protocol? IP route. Okay. Then you have to define the
IP
destination
route, IP address,
or the destination
destination
network.
IP address.
Destination network, not the IP address. IP address, a single IP
Destination.
address.
Yes, yes.
Okay, destination network, which will consist of all the IP addresses. Okay, IP route, destination network, then
Subnet mask.
Subnet mask.
what is subnet mask? Your subnet mask?
Destination network subnet mask.
Destination network subnet
Subnet
mask.
mask.
Is it? Then
Yes. Next hop.
next hop IP address, the directly connected interface IP address of your neighbor router. Is it?
Yes, sir.
Yes, sir.
Next
Or
hop
we
IP
can
address.
or we can use interface.
Interface of whom?
Exit
Interface of
interface.
whom?
Stop. Exit
Your interface or the next hop interface? Suppose from
directly
router 1,
connected
if you want to, on router 1, from router 1 to router 2, okay, you have to reach from router 1 to router 2. On router one side, you have a serial interface. Okay, serial interface. Serial 0/0. Okay. On router two side, you have what? A serial 0/1. It can be any. Okay, where you have a plugged the cable. Okay. So in this case, on router one, what you will define? Serial 0/0 or serial 0/1? Your own connected interface or the neighbor router interface? Hmm? What you will do? Your own connected interface or the neighbor router interface? It will be your serial
I
0/0 or
think
serial
we
zero
can
by
do
one.
for our like local interface.
Local interface. It will be always your local interface, not the next hop IP address interface. Okay, if you are defining the IP address, then you have to define the next hop. Next, the next means what? Your neighbor router IP address. Okay, but in the case of interface defined, if you define your serial interface name, so you have to define your own exit interface name, own exit interface name. Okay. Then after that, or completed, completed or something is remaining,
That's it.
Completed, sir.
completed. And after this, you can also define the administrative distance. If you want to define the administrative distance, it will take what? Default one. If you want to like make any changes, you have to make a changes whatever you want. Okay, so how like you can change your administrative distance in static routing of protocol. IP route, destination network, destination subnet mark, next hop IP address, and after next hop IP address, you can define the administrative distance if you want. If you want. If not, it will take an administrative distance of one default. I think so. Everyone know how to configure the static routing of protocol.
Yes, sir.
Yes, sir.
Everyone know about how to configure the static routing of protocol? Or anybody having a doubts on static routing protocol to configure it? It's just like it's very easy, I think, to configure
Yes.
the static routing of protocol. Okay, you have to define if you guys have like good in CCNA, then you know how to configure it, static routing of protocol, because it is not anything you want to get advanced in static routing of protocol. It's very less. Okay. Any doubt regarding
No,
static?
sir.
Done.
Can
Okay.
you
So tomorrow we will.
uh,
Tell me.
sir, how to configure static routing?
This will become an IP route network, destination network, subnet mask. Okay. Do one thing. Do by yourself. Okay. If you guys are getting some error or not able to do this static routing protocol, let me know. Okay. Then we will make one lab on this, small lab, not the big one, small lab on it, and we will do it together. Okay.
Okay, sir.
Everyone like agreed? Okay, do by yourself. If you guys are not able to do it, okay, let me know. Okay, we will do it together. Okay, everyone.
Okay.
So inshallah, tomorrow we will start by same time, but with the dynamic routing of protocol. Okay, in the dynamic routing of protocol will be your rip routing of protocol. We will start with the rip routing of protocol. Okay, all good with anyone having any such doubts in static routing of protocol?
No, sir.
Everyone
No,
is
sir.
good. Okay, bye for today.
So, sir, from
Everyone.
tomorrow, like the training timing will be like 9 to 10
Same
only.
9 to 10. 9 to 10 or 10:15. It depends how the topic is.
Okay.
Okay. Why? Because now if I will start the routing of protocol, we have to leave it in between only. Okay. So that is why I decided tomorrow we will freshly start with the routing protocol. Okay. Good with everyone?
Okay, sir.
Okay, sir.
Bye,
Thank
bye,
you.
bye, everyone.
Bye.
Thank you. Thank you.
Thank you.
Thank you.
Thank you, sir.